Hello, this is a perceptual learning activity and our hypothesis testing module 10B. And for this one, you can see that we have a fully worked out z-test, two-tailed z-test, where we start off with the null hypothesis distribution, a sample size and a sample mean. The standard error is calculated, the z-test is calculated, and then we actually have the z-test value. And everything up here is nice and it can help you with your learning. But for this activity, we're really just going to be focusing on where it says the z-test. We also have a helpful visual graphic of where is the sample mean. So if the z-test is negative 2.1, that's telling us that the sample mean was 2.1 standard errors below where the null hypothesis distribution predicted that it should be. And let me just remind you that for a two-tail hypothesis test, for a z-test, our cutoffs are plus and minus 1.96 standard errors. So if our z-test is negative 1.96 or below, we'll reject the null hypothesis. If our z-test is positive 1.96 or above, we'll reject the null hypothesis. If the z-test is within the plus minus 1.96, that is, it doesn't reach the boundary but it's within it, then it's in that like middle 95%. And that'd be a good place for it to be. It would tell us that the null hypothesis did a good job of indicating where the sample mean should be. For this scenario, a z-test of negative 2.1 means we're going to reject the null hypothesis. So it's outside of the plus minus 1.96 standard errors. So I'll reject the null hypothesis and support the research hypothesis for this case. Okay, here we have a z-test that's 1.9. So it's within the plus minus 1.96. Now if it landed right on plus 1.96, we would reject the null. Or if it landed right on negative 1.96, we would reject the null. But this is 1.96. It's close, but it's not enough for us to reject this null hypothesis distribution. The null hypothesis distribution continues to be viable, continues to be believable, so we retain it. For a z-test of negative 2.1, that sample mean was 2.1 standard errors below where the null hypothesis said it should be. So at this point, we're saying this null hypothesis distribution, it's not really good at predicting where the sample mean should be. If it was good, the sample mean should have been in this area. So like, and let's go with something else. I'm going to reject that null hypothesis. We're going to support an alternative hypothesis, a different way of trying to figure out where the sample mean is. Okay, so here we have a z-test of 2.13 that's outside of the plus minus 1.96 criteria. So we're going to go ahead and we're going to say this null hypothesis didn't do its job. We're going to reject it. We're going to end up supporting the research hypothesis. A z-test of negative 2.8. Again, the sample mean is out here, in the edge, and because of that, because it's not in the middle zone, but it's out on the edge, we're like this null hypothesis distribution just didn't do a particularly good job. We'll reject it. Again, 2.3, that's outside of our plus minus 1.96. We reject the null. Another 2.3, reject the null. And negative 4.2. That sample mean is 1, 2, 3, 4.2 standard errors below where the null hypothesis distribution said it should be. That's a pretty big miss, so we'll reject the null hypothesis distribution. A z-test of negative 3.5, again we'll reject the null. A z-test of 2.3, again it's outside of our plus minus 1.96, so we're going to reject the null. A z-test of negative 0.5, that's actually pretty good, So the null hypothesis distribution says that the mean should be 100, and the sample mean was 97.9. That's pretty close to where the null hypothesis distribution said it would be. It's in this middle 0.95. It's within the plus minus 1.96 errors. So given that it's within that plus minus 1.96 standard errors, we'll retain the null. Z-test of negative 1.8, we will retain the null. Z-test of 0.5, retain the null. Z-test of negative 1.8, again it's within our plus minus 1.96, so we retain it. Z-test of negative 1.8, retained. Z-test of 1.4, retained. Again, it's a z-test of 0.7. That's a pretty good result based upon our null hypothesis distribution. We're going to retain the null hypothesis. It's within our plus minus 1.96. So plus minus 1.96, that's always going to be a case if you're doing a two-tailed z-test alpha of 0.05. Z-test of 1.9, we retain. Z-test of negative 0.5, retain. Z-test of 1.2, we retain. Z-test of negative 2.8. No, sample mean is just too far away from where the null hypothesis said it should be. We're going to reject this null hypothesis distribution. Time to find something different. Z-test of 1.9, we'll go ahead and retain the null. Sample mean was in our plus minus 1.96 standard errors. Z-test of 2.3 we'll reject. Z-test of negative 1.8 we reject. I'm sorry. Z-test of negative 1.8, that is within our plus minus 1.96. We'll retain the null. Z-test of 1.0, retain the null. Z-test of 1.5, that's within our plus minus 1.96. We will retain the null. Z-test of negative 0.5, again, null hypothesis distributions did a great job of indicating where we should find the sample mean. We retain it. Negative 2.7, just too far away from the null hypothesis that it should be. We'll reject it. Z-test of negative 2.1, we're going to reject the null, support the alternative hypothesis. So there we go. That's how we do this PLA for the hypothesis testing module 10B. And we get a completion code 801. Your completion code will be different each time you take the quiz and different from other people. But whatever your completion code is, that's what you enter as your answer to the quiz. All right, take care.